7th graders, welcome to your 9th video. In our 9th video, what we're going to be doing is we're going to be doing the last lesson of the chapter, Chapter 1, Lesson 9, Direct Variation. Our objective is to use direct variation to solve problems in our standard 7th grade ratios and proportions standard 2, 2A, and 2B. Let's go ahead and start our vocab to start this lesson. Alright, for our vocab today, we have 3 vocab words. We have direct variation. That's the relationship between two quantities that have a constant ratio. We have a constant proportionality, that's a constant rate or unit rate of two variable quantities, and we have the constant ratio, and the direct variation is called the constant variation. So what this really means is that the direct variation is how we see numbers changing on the y and numbers changing on the x. Constant proportionality is that the fact that those numbers are exactly the same, that means we have a constant, which means it's always happening, it's always the same. And constant variation is actually the same thing as constant proportionality. All of these say that what we're going to do is we're going to look at information and we're going to say what is it changing by, and if it's always the same and it goes through the origin, it's a direct variation. If it doesn't go through the origin, not a direct variation. So we're going to look at that, and let's go ahead, start our lesson. Make sure you copy down your vocab. I know I was kind of in the way of this last word, direct variation. So there we go. For our key concept, we have kind of this idea about a little bit more about direct variation. A direct variation is a relationship. When you take your y and you divide it by x, you always get the same number. We're going to actually say that whenever we take y divided by x, we're going to get k. K means our direct variation, or our constant proportionality, or our constant variation. So the letter k is just representing what we got when we took our y divided by x. That goes right here. Now, if we're writing it in an equation, we leave the y alone, we leave the x alone. The only thing we change is the letter k, because k is our direct variation. As long as it's always the same number, it's a direct variation whenever we take y divided by x. Let's go ahead and look at our first example and see what I'm talking about. Alright, so for our first example, we have the height of water as a pool is being filled as shown in this graph. Determine the rate in inches per minute. Now, here's one of the things that we need to understand about direct variation, and this is kind of something that we might find familiar. If our graph goes through 0, 0 and makes a straight line, which means some of you might be thinking that means it's proportional. If our graph is proportional, then it's a direct variation. If it's a direct variation, what that means is if we have to find the rate, all we got to do is take our y and divide it by x. So our graph does what a proportional relationship does. It starts at 0 and it makes a straight line. Now, if I wanted to figure out what the rate is, since it makes a straight line and it goes through 0, 0, all I got to do is look at my coordinate pairs, like this is 5, 2. All we got to do is look at that, and we're going to say, well, this is the x, this is the y, this is the x, this is the y, this is the x, this is the y, and this is x, this is the y. If this is a direct variation, that means whenever I take the y value, and divide it by x, I'll always get the same number. Well, let's go ahead and check that out. I'm going to grab my calculator. Alright, got my calculator ready to go. Sorry about that. So what we're going to do is we're going to say, if I type in my calculator, 2, because that's the y, divided by x, 2 divided by 5, that equals 0.4. Okay, let's look at the next one. This is the y, this is the x. If I type in 4 divided by 10, I get also 0.4. So right now, those are also the same. Let's look at the next one. 6 divided by 15. Again, I get 0.4. And 20 and 8. So I'm going to take the 8, which is y, divided by x. Y divided by x, 8, divided by 20, gives me 0.4. So now looking at this, we see that every time we look at each one of these and we take the y divided by x, we always get the same number. This is what proves that we have a direct variation. A direct variation will always make a straight line and go through the origin. If it does, it's proportional, but it also directly varies as y changes. So what's going to happen is now all we got to do is take this number and put it over 1, and we have our rate. our rate tells us that the graph is moving 0.4 inches every minute. So this is us putting our label on it. And that's it for question number 1. Let's go ahead, try another one, and see if we can maybe get a little bit more grasp of what direct variation is. Alright, so for our next example, we're kind of doing the same thing that we just did in the previous problem. It says the amount of money Serena earns at a job is shown on the graph. So there's our graph. Determine the rate in dollars per hour. So looking at this, we can determine that this is a direct variation because it does two things. If our graph goes through the origin and makes a straight line, it's a direct variation. So our rate, which they're asking us to figure out the rate, is when we take our y value, divide by our x, and we make it a unit rate. So let's go ahead and do that. So here, looking at our coordinates again, we know that the first coordinate is x, the second coordinate's y, first coordinate's x, second coordinate's y, first one's x, second one y. Alright, so we have our x and y's labeled. If it's a direct variation, when I take the y value, like 160, and divide it by 16, I should always get the same number. 160 divided by 16 gives me 10. Okay. If I take 120, because that's the y, divided by 12, I also get 10. If I take 80, because that's the y, divided by 8, I get 10. And if I take 40, divided by 4, I get 10 again. So right now, I see that I constantly get 10, constant proportionality. So we are able to say that this is a direct variation because we're always getting the same number when we take the y divided by x. So this is our value of k. Well, all we got to do is put this over 1 to figure out our rate. And, like we always say in class, if you like it, put a label on it. So, we're going to actually label this. The y value is dollars, and the x value is hours. So that means that this person is making $10 an hour, and that's their rate. Let's keep moving. Alright, so for example 3, we have a word problem here. And this one is asking us to find the constant proportionality. It says the equation y equals 10x represents the amount of money y, so y is how much money Julio earns in x hours. X is how many hours he's working. Identify the constant proportionality and explain what it means in this situation. So this is where I'm going to backtrack to what we started with in this idea of direct variation. In a direct variation, your equation would be y equals kx. Whatever is in the spot of k, that's your constant proportionality, or your direct variation, or your constant variation. It's the number that represents what the rate is. So k is what our rate is. So now, if we look in this problem, it says y equals 10x. Well, that's telling me that 10 is in the spot of k. So 10 is equal to our constant of proportionality. Now, what this means in this situation is that since 10 is in the spot of k, this is telling us the rate at which he earns money. That means that Julio is earning $10 every 1 hour of work. Because we can always put any number over 1 if it doesn't have a number under it. So this is telling us how much he's making per hour. Now, the idea of this is, if we have the equation y equals 10x, and we were to plug a number in, like maybe 2, if he worked 2 hours, 2 times 10, he would make $20. So whenever you have an equation, that's where you can plug something in and get something out. You could put any number in here and figure out what he's going to make at the very end of the problem. So I could say, what if he worked 100 hours? I put 100 in for x, 100 times 10, that's $1,000. So if he worked 100 hours, he would make $1,000. So this right here is what this is telling us, though. Our constant proportionality is telling us, since it's in the spot of k, that he makes $10 in 1 hour. For example 4, looking at another story problem, this one talks about typing. So it says Neil is practicing for his typing test. The equation y equals 45x represents the total number of words, y. So the y represents how many words he can type in x minutes. So the x represents how many minutes have passed. So we can plug in how many minutes and figure out how many words he typed. Identify the constant proportionality, then explain what it represents. So again, our job is to figure out the constant proportionality. Well, looking at that, it says y equals 45x. That's kind of like the equation we were talking about earlier about direct variation equation. It's y equals kx. So again, what we got to figure out is what's in the spot of k. Y equals 45x is what they give us. So k, 45 is in the spot of k. So that means that 45 is my constant proportionality. So we can put constant of proportionality we have our constant proportionality. Now we actually have to explain what 45 actually means. Well, he's practicing the equation y equals 45x represents the total number of words he can type in x minutes. So that must mean that he can type 45 words, because that's the y value, in 1 minute, because that's the x value. So our constant proportionality tells us that Neil types 45 words per minute. And that's really it. That's all we have to do whenever we're looking at an equation. We find the constant proportionality, and we tell each other what it means. And if you read in the problem, they tell you that words is the y value, and remember that direct variation is y divided by x. And they say x is minutes, and so that's why I labeled it as words and minutes. Let's keep going. In example 5, we're going to read a story problem, and we're going to set this up differently. Right now, we've looked at graphs, and we looked at equations. So now we're going to change it up, and we're going to look at something else to be able to tell whether or not a direct variation does exist. So here it says pizza costs $8 each plus $3 for delivery. We need to show the cost of buying 1 pizza, 2 pizzas, or 4 pizzas. So let's go ahead and go to our problem here. Alright, so we're going to go ahead and solve this problem. So to do this, what I'm going to actually do is I'm going to show you how to do it with a table this time. And we have 2 variables that are happening in this table. We have how many pizzas, and we have the cost. So we're going to look at pizza, and we're going to look at cost. Now, chances are pizza is going to be my x value, because it's small numbers usually, and cost is going to be my y values in this case. So I have pizza and I have cost. Well, we need to find the cost of buying 1, 2, and 4 pizzas. So let's go ahead and establish this. If I bought 1 pizza, I have to pay $8 for that pizza. 8 times 1, that's 8. But I have to add $3 for delivery. So 1 pizza is going to cost me 8 plus 3, $11. 1 pizza is $11. 2 pizzas, I would take 2 times 8, because that's how much each pizza costs. That's 16. 16 and add 3, that means 2 pizzas would cost me $19. If I had to buy 4 pizzas, 4 times 8, that's 32. 32 plus 3, that's 35. So what we have to do is we have to say, does a direct variation actually happen between these numbers? And if it did happen, we know that it would make a straight line, and it goes through the origin. So if we really wanted to, we could graph this and then tell you if it's a direct variation. But I'm going to teach you another way how to figure out if it's a direct variation without graphing. We know that pizza is the x value, and we know cost is the y value. In a direct variation, our constant proportionality, or the letter k, is always equal to y divided by x. So all we got to do is say, do we get the same number when we take our y value and divide it by our x value? And if we do, it's a direct variation. If we don't, it's not a direct variation. So this is kind of like way back when we were testing if something was proportional. All we had to do was take the y value, divide it by the x value, and if it was the same, that's proportional. If it's not the same, non-proportional. And we know a direct variation is proportional. So let's do our old method. So the cost is $11, and that's our y. So the first fraction would be 11 over 1. And if I type 11 divided by 1 in my calculator, I get 11. The next one would be 19 divided by 2. And when we type that in, we get 9.5. And our last number would be 35 divided by 4. And we get 8.75. So looking at these three different numbers, we can see that this is not a direct variation because the rate is not the same. So we'd say, no, it's not. And I'm just going to go ahead and use dV for a direct variation and say the rate is not the same. In order to be a direct variation, we have to have the same rate. And that's really it for this part. Let's do one more, and I think for the most part, we're done. All right, for our very final question, or very final example. Example 6. What we're going to do is we're going to determine if this is a direct variation by looking again at a table. So again, first two questions we looked at graphs, second two questions we looked at equations, and now we're looking at tables. Let's do this kind of like we did the last one. If this is a direct variation, we know that our constant of proportionality, or our variable k, is going to equal y over x. And if it does equal y over x, it always has to be the same number in order to be a direct variation. So here it says that time is the x value and wages is the y value. So we're going to take our y, 12, and divide it by 1. 12 divided by 1, that's 12. We're going to take our y, 24, divided by 2, and we get 12 again. 36 divided by 3, get 12 again. And 48 divided by 4, we get 12 again. Since this is always the same rate, it is a direct variation. So we would say, yes, it is a dV for direct variation because our rate is always 12. So we can say that yes, this is a direct variation because our rate is always 12, and that's it. You guys did awesome for this video. Make sure you like this video, smash that notification bell, subscribe if you haven't subscribed so you get notifications anytime I upload videos, and I'll see you in class.